Radioactive decay. This is when things emit radiation. Uh, there's three that are fairly common. Alpha emission. This is where a big nucleus gets smaller, and this is uranium-238. It does undergo alpha decay, and so one of the ways to look at these equations, pretty easy. It's uranium-238. You can see the 238 right there, which means we know it's an alpha emission. So there's a 4 on top. That's the mass number of an alpha particle, which means 4 plus something has to equal 238. So that's where we get this 234 here. And the same thing goes on the bottom. This is 92 on the bottom. We know that an alpha particle has 2 on the bottom, so this has to be 90. And if you look at the periodic table, that's thorium, TH here. All right. Alpha emission happens when a big nucleus is trying to get smaller. Beta emission is when a neutron becomes a proton, which I think is absolutely bonkers. So here's carbon-14. Carbon-14, this 14 stays the same over here because in beta emission, it's electron and it has no mass number, so we know this has to be 14, right? Here, we know that -1 for beta emission plus 7 gives us 6, so this number has to be 7, gives us nitrogen 14. There we go, all right? That means, like, we're kind of going the other direction for beta emission. It's smaller atoms getting larger. And then positron emission here, it's the same thing. You guys can understand this. In positron emission, a proton is converted to a neutron. And so we get carbon-11 here, and we end up with boron-11 and a positron being emitted. All right, half-life. Okay, now we're going to have to do a little bit of math, all right, which is going to be pretty awesome, right? Right. Okay, so half-life is the amount of time for half of the starting material to change. All right. Now, as far as radiation is concerned, here phosphorus-32 has a half-life of 14 days, 2 weeks. Pretty easy. So if we start with 16 grams of phosphorus, all right, it's day one. After 14 days, we'll have 8 grams of it because it's half. Then after another 14 days, we will have half of 8. It's just you're constantly dividing by 2 over 14 days. It's 28 days later, and then 42 days later, after 3 half-lives, we've multiplied 16 by 1/2 by 1/2 by 1/2, or 1/2 to the third, and we have 2 grams left. So this is 1/8 of our original amount. So if we jump over here and say, okay, well, what does this have to do with medicine? It's one way we can measure drug breakdown in the body. What's the half-life of a certain compound in the body? One of those, which I had this morning, is caffeine, which I think we all have. And this T1/2 is your half-life. And so the half-life of caffeine in your body is about 5 hours. All right. So how long will it take 235 milligrams to get to 1/8 the original amount, which is coincidentally is just the amount in a tall pike place if you go to Starbucks. Anyways, how long will this take? Well, 1/8 of the original amount. So after 5 hours, we have 1/2. After another 5 hours, we have 1/4. And then after another 5 hours, we have 1/8, or 1/2 to the third. So it takes about 15 hours to get to 1/8 of the amount of caffeine that you ingested, at 235 milligrams. So I asked this question, what makes this difficult to calculate? There's a lot of moving parts in the human body. We all metabolize caffeine a little different, so it's going to be very individual, depending on your DNA. Also, it's not like you're taking this tall pike place and just slamming it back in one gulp. So you're not getting that 235 milligrams of caffeine immediately. You're sort of taking however long it takes you to drink, that's how long it takes you to ingest it. And so this is a little bit of an approximate. So, but this is the basic idea. As we go down here to slide number 6, slide number 6, pretty straightforward. It's just radioactive isotopes used in medicine, and it tells you what they do. EC is electron capture. Like I said, there are a ton of different types of radiation, kinds of radiation out there. And so I didn't touch on all of them. We just talked about the 4 major ones. But you can see here, you can see here these guys right here. That little Y thing is gamma, that little B is beta, and then we talked about the fish, that is alpha.